Coming up on Mayo Clinic Q&A.
And artificial intelligence is a form of very sophisticated pattern recognition. And through a process of repetition, maybe 100,000 times, where you show it an ECG, tell it what the right answer is, and it keeps tweaking it, it gets very, very good. And at the end, you have a math function.
That math function is an example of how artificial intelligence, or AI, is used in cardiovascular medicine. This enables for faster interpretation of the ECG and
If we do it right, it will detect diseases earlier so that we can begin treatment sooner, and it will more equitably balance healthcare resources.
Welcome everyone to Mayo Clinic Q&A. I'm Dr. Helena Gazelka. For many of us, we are living in an age of technology that we could only dream about decades ago, things that we saw in cartoons or on television movies. When it comes to technology, Mayo Clinic is a leader in bringing the tools and science of artificial intelligence, or AI as it is known, to clinical practice. When it comes to the heart, Mayo Clinic's artificial intelligence and cardiology work has looked at ways to use artificial intelligence both to predict and to diagnose heart diseases and conditions. Would you believe that there are even recent studies showing that artificial intelligence may be helpful in predicting COVID-19 infections? Well, here with us to discuss all of this today is Dr. Paul Friedman. Dr. Friedman is the chair of cardiovascular medicine at Mayo Clinic. Thanks for being here today, Paul. Welcome to the program.
Well, thank you. It's a great pleasure to be with you.
I am so excited to discuss this topic with you because it absolutely amazes me.
Well, thank you.
I think it's going to amaze our listeners too. I think one of the important things to understand, I know a lot of this work on artificial intelligence deals with electrocardiograms or ECGs. Would you explain for our listeners what those are?
Yeah, of course. So the ECG or EKG, it's the same thing. One is from Dutch, one is English, is the recording of the heart's electrical signals at a distance on the body's surface. And typically, many of us have gone to the doctor, you lay down, you get stickers on your chest, and those record the electrical signals, and we put them on a piece of paper. And it turns out that many of the diseases that affect the body will affect the electrical signals. Those electrical signals are governed by these tiny microscopic channels that let currents go through that are so critical to life that they've evolved little from bacteria to human beings. Because if you think about it, every thought in your brain right now, every breath you take, every movement is controlled by electrical signals. And so they're terribly important. It's not hard to believe that if there were a disease that were affecting heart muscle in any way, that those electrical signals might be disrupted and that it could potentially be an early finding.
So how does artificial intelligence apply to this?
Yeah, no, great question. So right now, as clinicians, as you know, we're learned to read changes, for example, a segment or a named feature. ST segment elevation means someone may be having a heart attack. But there have to be millions of cells that are having problems for that change to happen. And artificial intelligence is a form of very sophisticated pattern recognition. And the way it works is you feed an ECG into what's called a neural network. And it's called that because it's modeled after human neurons. You have a number of math equations. They're all one connected to another, just like neurons are connected one to the other. And you feed in an ECG. And then, for example, in the first network we built to screen for a weak heart pump, what we call a low ejection fraction, we would feed in an ECG and ask the network, is a weak heart pump present? And it would guess, it'd have no idea. And then we train it. So we say, no, this one is, it may say ejection fraction 25%. We'd say, no, this one's 45%. And then it changes the weights of all those equations just a little bit. And through a process of repetition, maybe 100,000 times, where you show it an ECG, tell it what the right answer is, and it keeps tweaking it, it gets very, very good. And at the end, you have a math function. And much the way you would show a child a fruit, and it's round and firm and has a stem, and you say apple, and the child learns an apple, the computer learns the same thing, but instead of one or two examples, it needs hundreds of thousands or millions of examples. So it takes a lot of computing to train a network. But once it's trained, you have a math equation you can run on a smartphone.
So it sounds like you've had to put many, many ECGs into the system with and without different diagnoses to make it accurate.
Yeah, that's exactly right. And one of the things we're really fortunate at Mayo Clinic is we have this huge digital data vault. And the people who came before me were very prescient. And we have a collection of just under 10 million digitally recorded ECGs, sampled at roughly 500 hertz, and they're part of the electronic medical record. So for any person's ECG, we also know what their blood test values are, what their echocardiographic or heart pump strength is. And so we can use that to train the network, because we need labeled data so that we can tell the network, this ECG shows a normal heart pump, this one shows a weak heart pump. And what we've discovered is we started with heart pump strength, and we've gone on to identify a whole slew of conditions that affect the heart muscle. Some are primary cardiac, some are not, so that we can develop a screening panel. And ECGs used to require you to lay down and put stickers on your chest, but as you know, you can now get it from a watch or a smartphone. So it makes it a very powerful tool.
Paul, this sounds like this has come a long way from when I was back in medical school, learning to measure little intervals on an EKG with a caliper. And they always said, don't believe the machine and what it read. You have to read the ECG yourself. Do you
Yeah,
remember those days?
I definitely do. I definitely do. Increasingly, we need to learn to believe the machine, although as always, it's a tool and we use it with judgment. And you know, people say, is AI, speaking broadly, going to replace us? Will it do everything we do? And the way I look at it is this: if you want to go for a walk on a dark night, you're going to take a flashlight. And with a flashlight, you'll be able to see, but the flashlight is empowering your eyes. It's not replacing them. And so these are powerful tools that will let us see deeper and farther into the future.